Let's say I was told to write a function that consumes a list of numbers and produces a new list with every number squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9. This is the map square function, consumes a list of numbers and produces a list of numbers, consumes a list of numbers and produces a new list where each number has been squared. We'll define it. Map square consumes a list of numbers, dot, dot, dot. We'll write our check expects first, as is tradition. Map square on the empty list produces the empty list. Easy enough. And the check expect on map square of the list 1, 2, 3 is list 1, 4, 9. So each number gets squared, multiplied by itself. We get to use our familiar list handling template. We test if something is empty. If it is, then we return the empty list. Otherwise, if it's a cons pair, then we'll need to do something with the first of the list and something with the map squared of the rest of the list. Now, the goal of this function is to produce a list, so we're going to cons together whatever the result is. We need to cons the first with the mapped squared of the rest. When we cons in the first, though, we also need to square it. And we end up with, missing a parentheses. There we go. And we run to make sure that our unit tests pass. All is well. Okay, so that works pretty well. What if someone then came along and said, all right, now I want a function that consumes a list of numbers and produces a new list with every number increased by 1. We could almost copy the entire code for map square verbatim with only a small change. So let's do just that. We're going to steal a bunch of code from ourselves. Ha ha ha. How nefarious. All right, so now we're going to do map add 1. We put add 1 here. Our recursive call changes. We actually change the name in our calls. 1, 2, 3 changes to 2, 3, 4. And the only thing that actually has to change in terms of actual different code is putting add 1 instead of square. So we had to change the names. The type didn't change even. Map square became map add 1, and then we had to change the call. If people kept asking us to make functions that apply a single function to a list of numbers, it'd be time to abstract out a more generic function. Abstracting functions means to take something concrete in the body and to turn it into a parameter, thereby making the function more generalizable. I'll abstract out our map square function into a more general function named mapper. And to do so, I'll abstract the square function and the map add 1 function into a new parameter. So this time we're going to write a function called mapper. Consumes a list of numbers and a function that consumes a number and produces a number, all of which produces a list of numbers. So here once again we've got a function that consumes a function as the second argument. Consumes a list of numbers and a function producing a new list where each number has been modified using the function. So we'll define mapper consuming a list of numbers and a function, dot, dot, dot. And let's write our check expects to better understand what this function looks like. So calling the square function using our mapper on an empty list produces an empty list. But if we do this on a non-empty list, like say the list 1, 2, 3, and we use the square function, we should get the same result we had before, 1, 4, 9. Similarly, if we call mapper on the list 1, 2, 3 and pass the add 1 function, now we anticipate 2, 3, 4. So we were able to accomplish the same thing as before with a much more concise function call. All right, let's actually write this function. So we have the cond with the empty case still produces empty, and then we have our cons case. And in that particular case, we'll copy the exact same code we used before with one major addition. This time, instead of calling add 1, we're going to call a function. What is the value of a function? Well, we know it's a function that consumes and produces a number, but besides that, we actually don't know what it is. And we don't care what it is. As long as it doesn't violate the contract, we'll still maintain the correct output. When we call it this time, we pass in the square function, so a function ends up being substituted for square, and the second time we pass in add 1, and it does the same thing. With the function successfully abstracted, I can reuse it in endless ways. I could pass in my own custom functions that double the numbers, or halve the numbers, or do whatever I want. However, I am restricted to passing in functions that meet the signature, number to number. It has to be a function that consumes and produces a number. We must always honor signatures, or we are no longer civilized, and other programmers will not associate with us.